Good morning. My name is Pandita Melia. My ID is 25C023. My project is on the hardware Trojan detection. This topic is very important in the field of the cybersecurity and electronics. What is a Trojan? A Trojan is something that looks safe and friendly, but inside it is dangerous. A Trojan is type of the virus, like a bad program. It pretends to be a game, app, or a file, but when you open it, it can steal your data, damage your computer, let hacker control your device. What is a hardware Trojan? A hardware Trojan is the malicious circuit alteration done by the enemies. It will have unfavorable on the system. It is defined as emerging threat. They integrate circuits and their application. Now see, impact of the hardware Trojan. A hardware Trojan causes incorrect system operation, lead a lots of confidential data, allow remote and control of the device, can disable or damage the system, reduce overall system security, may causes failure in critical system. Now we see life cycle of integrated step. Understand where Trojan can be inserted. We look the life cycle of the integrated chip. It includes design phase, fabrication phase, testing and packing, deployment and application, end of the line. Let's discuss in brief. Design phase. Define system develop architecture and using EDA tools, integrated IP cores and standard cells. Fabrication phase. Generate photolithograph, IC marks, manufacture chip in semiconductor foundry, build circuits on silicon button. Now we see testing and packing, perform functional and function and quality testing and identify and removed it the defective chips, package chips with a protective casing and PI. Now we see deployment and application, distribute, manufacture, integrate into electric device, monitor performs during the operation. End of the life. See device disable or recycling, recovery and useful material. Now we see concept need for a hardware Trojan horse. First, trigger starts the Trojan. When a specific condition happen, it activates the hardware Trojan. Second, action is decided after trigger. One triggered, what to do next is stored in the memory controlled by the sequential circuit. Third, driver performs the action. The driver carry out the action that was activated by the trigger. Now Trojan detection. This is in two part. Let's see the first one. Destructive chip is physically open. Internal structure is checked. Chip get damaged and cannot be reused. Now we see non-destructive. Detect Trojan without damaging the chip. Chip is tested while it is working normally. Safe can be used again after testing. Now we see the logic testing. Apply different input the chip, compare output with the expected result. If output is wrong, possible Trojan. Slide channel analysis. First is observe power. Power ramming heat Trojan causes small changes in the signal. Compare with the two normal chip behavior. Now we see signal electrical analysis. Check internal electrical signal, detect unusual path or activities, identify abnormal switching. What is being built? What is being built? ROP, ring oscillator physical unable function, a hardware security technique used to generate a unique ID for each chip. A total of 512 ring oscillator are used in the design. A ring oscillator in a loop of the NOT gate that keeps switching. Each arrow produces frequency. Here 512 arrows are used. Increase randomness, improve uniqueness and reliability. More arrows, better security. Each arrow is manually mapped using the FPGA editor tool. FPGA has a many small logic blocks placed physical on the chip. Manually mapped means designer choose exact location on each arrows on the FP, not left the automatic placement. Why? Because this placement affect the behavior. Why this is useful? This tiny difference causes each arrow to oscillate at a slightly different speed than compared to arrows which is faster. Output 0 or 1, repeating this many times generating unique binary key. Power slide channel analysis. On normal condition, when the circuit is clean, current and voltage say almost the same, means everything working normally. When Trojan is present, Trojan add extra hidden activities. This causes small changes in power like extra load on the system. 3. Detection idea, we compare normal power versus changed power. Ring oscillator based on the arrow curve. Concept. Ring oscillator generates the frequency signal due to manufacturing variation. Each arrow has a different frequency. Working. Use multiple arrow oscillators. Select two arrows at the time. Compare their frequency. Output generation. Faster arrow output 1. Slower arrow output is 0. Multiple comparison binary sequence. A result generates a unique ID to output. Same chip, same ID, different chip, different ID. Trojan design used a structure consists of 3 XOR gates and 2 NOT gates connected in a series. Input taking input from LFSR controlled by enable signal. Input passed through the XOR and NOT gate. Each stage used output of previous stage generates modification signal at the output. Output produce Trojan output signal activity only when enable is on. Power analysis, voltage variation. Observation, measure voltage waveform of the circuit, monitor behavior during the operation. Normal condition, Trojan inactive, voltage remains stable and consistent. Trojan activity condition, extra hidden activity occurs, causes small voltage variation, slight change in the voltage level. Observation. Detection, compare normal versus acting voltage. Any deviation and index possible Trojan present. This is the conclusion. Thank you.